Okay, so we are live this evening, and we continue from where we left off yesterday. We're still doing boxing errors, which is the last thing that we want to study inside of error handling for us to actually solve the rustlings there. So yeah, this is the Rust language reference, right? So we're gonna go over this the way I try to do it. If there's something that I don't really understand or is not very clear, we would look it up in the standard reference and also try it out, like try out the code. Yeah. So let's get to it. Okay. So so these boxing errors. I mean, we learned about the box type yesterday, like how it works. By the way, I'm starting a bit early today, so it's like I don't know, 30 minutes early than my planned stream for today. But yeah, I think yeah. So let's do it. So we learned about the box type yesterday. So box is really a smart pointer. So it points to a location on the heap, right? So yeah, that's really what it does. So you really can use the box type to basically get like just a pointer, really, or reference, right, to a location or to some other place. Usually, the box, I mean, the pointer itself would normally live on the stack, right? So as would normally live on the stack, but it can also live on the heap. But yeah, that's mostly what the box type would be is used for, just a smart pointer, and then you you can use this when you deal with generic errors. So when you want to create our own error types um, or get an alias for a type. Yeah. So let's go on. So we had a program previously, double first. Just this one here. We wrote it. It's also from the previous things that we learned. So double first. This is it here, and we were using the. So what we're doing. So we're taking a vector, so it was taking a vector of string slices and would return a result of I32 type. And this result is not the result from the standard library, but instead a type that we created an alias for ourselves, which is like the generic or double error, right? And double error is a struct that we had. So this was the previous version we had, where we were converting the option into a result using the and then function on it, and then we were doing the map error, and just uh, this was the function as well, right? So we were parsing this, doing the map error, and then doing the map on it. Yeah. So that's it. That's what we were doing previously. Now this is a different version of the same program or the same function that instead does. So it's still going to return an I32, but this result type here is different. So it's like it's going to be result uh, or box. So in the error variant, so the OK variant is the result is a type, the generic type here, and the error variant is box din error. Yeah. So basically, a generic error. So this can hold, uh, yeah, a generic error here. And then what happens is that now we do OK or else. So before previously we did OK or. Previously we did OK or, and we were doing a map to error or a map error. So basically, this would OK or error would um, actually, uh, I believe we can still do that, right? We can still do. Okay, I think it's because I wanted to use this into empty vec is a struct that was created, so we can call that. We can also do ours. and then we have into. So into is a uh, what will into be? We should see what that is actually. So emptyvec implements debug and clone. I want to see what into. I mean, I can see already that into would map the error. So okay or else would return a result that is a result. Otherwise, it would do this. Yeah. So it would. This is empty. Yeah. So it would be like a supply or something. I think if you were to talk about in Java terms. So it's empty, and then it will do. It would convert error. I mean, let's write this. Let's write it. Double first. Um, I don't know. I'm just gonna call it boxed. So again, it's a vector of string sizes that I'm going to return for us. And I still want to leave this here actually. No, I cannot because I want to compare it. Okay. So let's leave this. Let's do it like so. Now we're gonna have a type. So yeah, I can actually call this double first right now. I don't need to box anything. And then let's do a type result. Um, yeah, and it will be result of I32 or like box in, yeah, okay. And then now this would then return for us result. As this is our result type. Yeah, yeah, our result of I32. That's it. And then we take the vector, we do a first, get a first element, which will give us an option. And then we say dot. We need to convert this option to a result because that's what we want to get out of it. We can do OK or like we were doing before, which would transform the option into a result, mapping the OK variant into mapping the sum variant into OK and the rest, right? But then there's also OK or else, which OK or else, which is self, of course. And then the second thing there is a function. Mhm. Okay, so why did we not use OK or? It's gonna be the same thing, yeah. I think it's just okay. Hmm. Okay. So okay or it will take the error, right? So we can say so here's the error is gonna be here. So we have to then put the error here, right? So I think here we had it was called double error. What was it called here? Empty vec it was called. So if we do OKR, we have to pass the empty vec here. Uh, yeah, and then continue processing. But if we were to, that's if we did okay or we provide the error. But if we do okay or else would be a function. We have to provide a function here. So that's the difference. Look, yeah, that's the difference. Interesting. Mm, so the OKR, we do them. Mm, wait. So you have X as some foo, and then you say X OKR, and then you pass a value. Okay, yeah. Yeah, okay, so yeah, I think that's what was okay, yeah. Again, we're converting from an option to a result. Yeah, that's it. So um yeah, we're converting it from an option to the result, and of course the result has the okay variant and the error variant, right? So then that um then it should be okay. So basically when you what you pass into the OKR is actually the error, right? So it's a you pass the error type because again, error is a so if we go to results now, for example, yeah, it's what's wrong with my internet? Why is it slow? But anyway, yeah, so if we go to the result tab, you will see that the result has the OK variant and an error, which both have types, right? So I think we can also see it from here, even there. So the generic types. So yeah. However, if we were to do the OK or else, like so, yeah, we would be providing an error function. And the error function, the error has to be a function. And for what we see here, this is how um, you provide an error function and you can start it with empty, what was this called? It's called pipes in like Angular and other languages, but I don't know what it's called in Rust again. I think there's a name for it. Yeah, don't remember now. But then this would just be a function. That's it. This is it. Okay. So yeah, but then it's so okay or else you define E and F. I mean as generic types here, and then you have self, and then you have an error that is a function or e of type f, error of that is of type s here, and then it returns a result that is of t, error t, and e in this case. So here, if we have x to be some foo, yeah, an option of some foo, x dot OK or else, we pass this here, 0. It's OK foo, yes, because it converts the sum variant to the OK. And then you have an option of string slice that is none, and then you do OK or else this, because it's a none, then you get error 0 as a type that will be there. Okay, okay, that's fine. So now we say OK or else, and then we can do this, and the type in the error here, we can simply um, do empty vec, but we saw that there was into that you can do, right? So what is into? Into what is into? Is it the traits? No. Um, I think we don't have much information about into here. Anyway, let's write it. I mean, I want to see what into is. Wait, what? I know what's wrong here. Okay. So the struct, and then you have into. Are we able to say into? I think we have think have problem with this. I hope I'm still online. But anyway, the let's continue. Uh-huh. So now I think we start to see the issue. I'm not sure what's going on, but yeah, let's continue. So you do that into, yeah, and then what? So so now into tries to get that convert this to an error, and what next? What next? So you would have yeah, and then otherwise what you'd have from here should be okay, yeah. So if I say this, yeah, I have a result of a type that is not, I don't know, like I don't know what the type is, because like, so this is, so I'm gonna get the okay variant back in this case, right? So now I can do dot I can do dot, I think I should be able to, I mean, if it's I have the okay, I have a result, yeah, I have a result right now. I can map the result. No, wait, yeah, I can map the result, and maybe like, I don't know, the value there. Yeah, the value here, I will get the string value, and then I can parse this, yeah. Yeah, I can do val dot parse. Oh, come on. Yeah, I can parse this, and this would give me a uh, an integer value already. I mean, this would already give me the value. So maybe I don't need to do a map here. Maybe I should instead do a and then because I want a function there. Yeah. So and then I have a val. I can do um yeah, this if I try to parse this at this point, I mean if I do val.parse already here, this is already an int. Yeah. So here I have a result. Next, I say I get a value that is here, the string, and I parse it. I mean, what I want to do is that I convert this to a string. After converting it to a string, I take the value that is an integer now, and then I do something with it. So why can't I do yeah, because exactly. So this would already why can't I do a dot map? Can I do a dot map after this? Yeah. Because yeah, because this would give me yeah, so I should be able to do a map to take the OK value, right? So yeah, which is the I32, and then I say val now times maybe it's easier to just say call it n. Why not? Okay, so what's wrong? Let's see. Mismatch types. This is the parsing error. Oh yes, because okay. Yeah, because wait, why does into why does why does into hmm, okay, something like this into that into doesn't actually give me it doesn't convert it for me. I mean I still see that what gets returned from here is a parsing error, but that should be fine, right? Because look, it says it's gonna convert to a box. Oh, okay. So going by that, mm, okay, okay, I see, which makes sense. So basically, what that is that this would not be like so, but instead, inside of here, I mean, we make this a uh because this is a so the and then is a function, so we can expand this. I mean, from what we see, that's done there, and then do a val dot parse, and then we say map error, for example, and then you do, wait, hold on, map error. It maps the result PE to result EF. It only maps the error, not the, yeah, so leaving the OK value untouched. Yeah. So essentially I can do, hmm, O. What is O here? Okay, yeah, it's a function. We can convert this, yeah, at least based on what we're seeing. Otherwise, yeah, exactly. I think we can do this. I mean, I think we just saw it anyway. But if this succeeds, then you do a map, right? Okay. So closure is expected to take one argument, but it takes two. What, you just do this? Is that it? Here. So what it says, the traits bound empty vec. Wait, no, that's not it. This is meant to be a function. Yeah. What are we missing here? Okay, so what? I think I want to understand this error. So the parameter t is not never used, first of all. We create a type, generate. Okay, this should not be 32 like directly, it should be t, and then it would work, first of all, right? Like, and expected what result, I think, yeah. So that one is taken care of. And then that's fine. You have the trade bound empty vec into the trade bound into boxed in std error is not satisfied. So the trait error is not implemented for empty vec, which is required by into. So the trait error is not implemented. What do we need to implement on empty vec to make that happen? So it's empty vec uh, implements debug and clone. What do we need? It's debug and clone that are here. Nothing more. Oh yes, display is missing. Um, I think I want to write this by hand. I was writing this by hand, so that I remember I also enjoyed getting used to the syntax. What was that? Display. FMC display. I think it's called, yeah. Actually, best to do it like auto trace missing function FMT. Let's just return. It takes self and takes mutable reference to a formatter and returns the result. I mean, you also have FMT result. Wow, like why do we have so many result types? Okay, I think it's not just right. Yeah, right is a macro. Okay, I think, but with right now with FMT with display now, I mean that's not what would make this not work. Yeah, or rather, that's not what this error is about. That's a different error. So what is this? The trade bound, the trade bound empty back into is not satisfied. Why is the trade bound for error? Actually, this is a different one. What's trade bound for error? Not satisfied. What is the issue? So you cannot call empty back into and then what? Come on. What's wrong with the network? I have no idea. Where the trait error is not implemented. If I look here, what did they do differently? Empty back into, you have okay or else, and they say this converts it. What is, um, Oh shit. Yep. I see it. It's very clear. If the trade bound is not implemented, it's because it did not implement it. So you didn't implement the trade bound. So there's error trade bound actually. And then you can just use a default empty. Okay, so that's why it couldn't do that. Okay. Okay. That's fine. That's fine. So now we have that being able to be copied over, or at least sorry, not copied over, converted, yes. And then what? And then we still have trouble with these. What does it say? Let's see. Mhm. Map error required by this bound. Okay, so it says complains that type must be known at this point, cannot infer the type of the parameter or declared method in the pub. So, okay, so it cannot infer the type here in map error. Why is this not? So map error takes okay and error. Wait, hold on. You have a result and it tries to convert the result T into TF. It's really just going to convert only the error to a different type. That's all. And an example usage is like, yeah. So so basically if I say this is the result type, if I say this is the result, okay, yeah, exactly this is the result because this is the error, then it should now do uh empty vec. Like this, why will this not work? Yeah, it will work. But then the thing is, error is not used. So what other way would we do this? Arrow is not used. So what if I say, because arrow is not used, what if I do this? Um, yeah, that's also, what if I then say this? That is also fine. But what if I go further and I say this? No. Looking at going to take one argument but take zero. How did you do it here? Okay, so you have to say the type. Okay. Yeah, you can do this, or you can just put an error type here and say maybe error, the error type. Okay, then that works. Okay. I mean, I still didn't see how the inter functions. I'd love to see it, but